Thank you for joining in on the webcast. We are actually starting the real webcast now. That was all just pre-show banner. We tend to do that as well as a little bit at the end. Just like to have a little fun with it and give you guys an idea of what you're getting yourselves into listening to us. On the webcast today, you have two of my most favorite people in the whole world. You have Bill Stearns and you have Mr. Keith Chew. Bill, I have known longer than I've known my children. Bill and I go back all the way back to the 90s. The first time I met Bill was at a Linux install fest, of all things. But just wicked smart guy, wicked nice guy. Has just created an amazing number of tools over the years. I can remember we were at an organization where we had to kind of declare what software we've developed that the company can't own because we developed it outside of that organization. And like, Bill needed like 100 pages. You know, I'm not exaggerating.
It was 1,006 different projects that I had to declare.
Yep. So he's been at this forever. Does a great job with this stuff. So you got Bill, so that's cool. You also got Keith. Keith is also awesome. One of the things I love about Keith is like, I just keep dumping stuff in his lap and he's like, sure, I can do that. Sure, I can do that. One of which is kind of the foundation of where this webcast came from, which is, hey, Keith, so every day I want you to take a new piece of malware with a different type of C2 channel and set that up and monitor it and see what's involved in trying to catch that. And, you know, add this into your workload every single day, but keep doing all the other stuff you were doing, okay? And, you know, Keith's response to that was, as usual, sure, yeah, I can take care of that, no problem. So Keith's been doing a lot of documentation around this, seen a lot of this stuff. So I think it's really cool we got these two folks to be able to kind of walk you through this process. Topic today is how do you test your tools? And we kind of hit on this during the pre-show banter. We have a bad habit of like buying security tools and trusting the vendor, sorry, when they say this is what we do, that they will do what they say what they do. It's never a good idea. It's always good to know your weak spots. You know, a vendor might actually do network threat hunting like they say, but there might be some things they don't detect. And unless you do the testing, unless you kind of verify that for yourself, you don't know where your own blind spots are. The fact that they have a weakness is not necessarily a showstopper if you can augment through some other means. Like maybe you say, okay, I like this tool, I'm going to use it, but it has a blind area here, but this other tool, I can fill that in with that. Great. Now you've got a nice layered defense. That's awesome. So this is what the folks are going to talk you through today is how to do that testing. And with that, I will drop off, go away, and let you guys have at it. Take it away, folks.
Hey, thank you so much, Chris.
Thank you, Chris.
Chris is exactly right. We're going to talk about how you test your threat hunting software. It's not about a particular package. It's not about a particular tool. We want to show you the techniques, and we're going to give you some pointers to some other places to get more information and learn how to do this yourself. So we're going to go through what the approach is, how you set this up. I'm going to show a little bit using built-in tools, testing your threat hunting software. Keith is going to jump in and show you with some real-world malware, Metasploit, and talk a little bit about that. And there's time for questions at any point. So if you've got something that doesn't make sense or we didn't cover it well enough or you just like to know some more, feel free to post it over in the GoToWebinar questions panel. We have people who will be looking there and we'll try to answer as many as we can. We also have the Discord channel set up. We encourage everybody to join the threat hunting Discord server. This is separate from the Black Hills Discord server. Both are absolutely worth joining. And this is where we want to talk about threat hunting in general, both network and host-based. All right. Keith, anything you want to add?
No, perfect. Thank you, Bill. Take it away, and I'll jump in later on.
You got it. So one of the reasons why we wanted to do this at all was to let people who said, well, I've already got a threat hunting package in place. You know, we're all set. We wanted to let them understand how to test that all the features are working. Is it catching the kinds of traffic that you want it to? If it isn't, why not? What is it about this particular type of traffic that's not getting caught? So are there gaps in your software? Is there something it just doesn't know how to catch? We happen to write one. We're not going to talk all that much about it today, but we will kind of go into a little bit more detail at the end of the webcast. So in 55 minutes, we'll switch over and talk a little bit about the one that we write, but we're trying to keep this away from being a sales pitch. We want this to be usable no matter what threat hunting package you've picked. If we can't catch it in our main package, can we catch it somewhere else? Is there another tool that we can use? Is there some other technique that we can use to fill in that gap? And that's just fine. When you've got regular audits, let's go and make sure that the threat hunting software is doing what it should. So maybe once every 3 months, you go and you set up a test like this. You still check that everything's working, that nobody is unplugged the Ethernet cable plugged into your span port and plugged it back into another port, and all of a sudden you're not capturing anything. This is a good time to make sure that everything's working. And the span port itself, did you configure it correctly so that your threat hunting package will actually receive all of this? I'm talking very vaguely. We'll get down into some very real world examples very quickly, don't worry. So the approach we're going to take is we're going to have two separate systems. I'm just calling them internal and external. Where they're physically located is totally up to you. If you want to keep this all inside your building, you can have this in just a single lab with a single switch and both machines connected to it, and then your threat hunting software connected onto a third port. I would rather do this with your actual threat hunting platform. So having one machine on one side of that threat hunting platform and one machine on the other side so that the traffic flows by and you can see that going, that's what I would encourage, because then you're testing that your production threat hunting system is working like you expect. Up on our blogs, we have a series of, I think it is 9 blogs, starting with threat simulation, overview, and setup. And this is part of a series where we talk about the full process of this, the actual commands you need to use, the tools that are included in your operating system to do this. What do you need to run? How do you actually get it working? So this is the starting point for everything, threat simulation, overview, and setup. And then I'm going to scroll to the bottom. This one has a link to all of the other individual traffic types. How do I actually check each of these? And these are all separate blogs. So for example, there's a separate one for DNS, and that's I picked the wrong document, but if you click on the DNS one, you'll go right there. I'm going to head right back to the presentation though. So we generate the traffic on the internal system, we make sure it's received at the external system, and we make sure that the threat hunting package will actually see it in the middle. All right, even though we recommend some particular tools, use anything you'd like. We want to make sure that this is tested in a way that you can do it easily. So we pick just some stock command line tools that are likely to be included in your operating system, but you can use any tools you'd like. Simple network layout. You've got some kind of switch with a span port, or you've got a firewall, or you've got some kind of packet capture infrastructure. Doesn't matter what it is. As long as your threat hunting package can see the packets between the host and the outside machine, we're all set. That's the primary one to focus on. Your firewall, we'll talk about that in just a minute. You need to make sure your firewall allows traffic from the host to your external box, your command and control server in this case. And it also, the response traffic needs to be allowed back in. We'll talk about that in just a minute. What do you use? Well, I tend to encourage Linux systems, but there's nothing about this process that is specific to Linux. So if you like FreeBSD, if you like Windows, if you like Mac OS, go ahead and use whatever OS you want. We're using Linux as a starting point, but many of the tools that we talk about will be available on other platforms. Keith will talk in just a minute about using a Windows box as one of the infected systems. The blogs talk about the individual tools that you need, and in many cases, how to install them. And these don't have to be big boxes. These can be very small virtual machines quite well. So spin up a cloud server if you want something outside the network. and an internal box running inside VMware or VirtualBox or KVM, anything you want, QEMU, you're all set. When you set these up, we don't encourage you to have a whole lot of open ports. Allow SSH or VNC if appropriate. Make sure you've got passwords and they're not default passwords. But other than that, no big requirements. Just keep it so there aren't a whole lot of ports for other people to attack. We also discourage the use of production machines, and the reason is you stand a small chance that some device inside your building, up at your cloud provider, at your ISP, at the ISP at the other end is going to detect this traffic and say, ooh, that really doesn't look good at all, and blacklist you, block you, firewall you, ban you, pause your cloud server. This is really better when you've got something that isn't a production system. Yeah, Chris.
So a couple of questions already that I wanted to toss out to you guys. Is this limited to internal to external threat hunting only? Or could I adapt this in a way that would allow me to check for lateral movement as well?
So we primarily talk about internal to external threats, because when you have a command and control server that needs to talk to an infected internal box, you need at some point to get traffic in and out of the building. There's nothing about this that is specific to traffic going in and out of the building. You could also monitor for traffic going between systems in your network just as easily. We don't distinguish between the two in this talk.
Agreed. Comment was, this is a great way to test MSSPs to make sure they're actually doing what you're paying for. Absolutely. If you have a third party monitoring this stuff, try this. If they don't tell you it happened, you've got a problem there.
Agreed.
There was one other question I wanted to throw in on this as well. Oh, yes. Advice for like a VMware environment. So if I'm, want this all isolated, I'm going to run it on a VM, I can't run a span port. So any recommendations?
Yeah, that's one of the reasons why trying to do this all inside one particular VMware instance, VMware ESX, VMware Workstation, or any other virtual platform, it's tricky. You're asking for a difficult challenge that distracts you from the main task of testing your threat hunting package. So my best suggestion for that is don't try to go and set up these massive infrastructures and private network segments and then some kind of virtual network tap that you may have to go out and buy, and you don't know if that's going to work. And just do yourself a favor. Try to keep this simple. Set up a virtual machine instance on the inside. That's just fine. Have a cloud server on the outside and do your testing. Focus on the real task of testing your threat hunting software. And because Chris has stepped away, I've automatically answered my question. Feel free to follow up if you have other questions. Border firewall, pretty straightforward, but just remember that any traffic from the internal system to the external needs to be allowed. Most everybody these days will have a stateful firewall, so that will just be a matter of saying if it's going from internal to external, allow it. Oh, and by the way, a little checkbox that says allow all replies as well. If you are unlucky enough to have a router or a stateless firewall that doesn't have that ability, no problem. Just make sure you allow all traffic from external to internal. This is another reason for not using production machines. You want to want to identify this traffic, and you want to keep it off of your legitimate traffic. You want to have a way to distinguish between them. It's not a great idea to leave it there forever, but for a short-term test or an audit, that's just fine. All right, now to get to the meat of this, we're looking for the different types of threats. And if you go to that blog that I talked about earlier, we have a list of the different types of threats there are. You can have long connections, you can have DNS traffic, tunneling of malicious traffic. You can have beacons, invalid signatures, TLS signatures, client, user agents, and so on. We have individual blogs for each of those. So the idea is that you go over the setup for those, We'll talk a little bit about that in this webcast, but more detail in the first blog. And then you say, which of these types of traffic do I want to test for? You go grab that blog and you follow the instructions there. Because it may take a while for these results to show up, what we encourage you to do is to set them basically all up at the same time. You can use the same internal system and the same external system for all of them. And we can leave all of the commands running that you need so that you can look later and say, did my threat hunting system detect these? Today we'll look at DNS traffic. And just as a quick reminder, while DNS is obviously a legitimate part of the internet, DNS also can carry conversations between an infected internal system and an external command and control server. So what we want to do is look for the patterns that show up when an infected system is using DNS for this. One of the very common patterns is for the internal system to talk to the external system and place millions, hundreds, thousands of requests, all to the same domain, but with different host names attached at the beginning. So a1.example.com, a2.example.com, bbb77.example.com, a.b.c.q.example.com. And all of these queries are effectively bogus, but they mean something when the infected system talks out to the command and control server. So what we're looking for is large numbers of queries to a single domain that doesn't make sense. A legitimate use of a domain would include maybe 2 or 3 or maybe some more, but maybe up to 10 or 15 queries in a very, very large network, but not hundreds and not thousands of different queries. That's what we're looking for. In this case, we're going to place these queries at a very regular interval, and that is beacon traffic. So when we're setting up this one particular test, we're actually going to look for 2 different types of traffic simultaneously. DNS queries with a lot of queries to one domain, and beacon traffic, regular packets that show up on a separate screen of the threat hunting software. So let's do a live demo. I'm going to send out a bunch of DNS requests to an external system. The external system in the case of actual malware will send back some kind of reply. In this case, it doesn't really matter what the reply is. I just need to go and generate the requests. But the request and reply pattern back and forth is how the internal system notifies the command and control server that it's there and that it's ready to do something. And then on the reply, the command and control server can send back, oh yeah, hey, I'm glad you're here. Would you please scan the internal network and tell me what Windows systems you have, for example? Yeah, Chris.
So 2 quick questions before you jump into the demo. Kind of a broad question, but do you have any recommendations for resources on hunting Active Directory attacks?
I do not.
Cool.
Let's go and put that out to the threat hunting Discord. Yeah. So if you go, would you please repost that question to host? How do we phrase that? I forget the name. System hunting, #system-hunting on the Threat Hunter community Discord, and let's see if somebody else has got a good answer.
I can take care of that, not a problem. The other question is, what if endpoint traffic is encrypted via a SOX proxy from the system itself to that proxy? How do you have to kind of change this up to be able to simulate a similar environment to that?
I love that question because it actually covers a couple of different ones at the same time. And the key word there is proxy. There's some machine in my building which is taking requests from lots of computers, aggregating them, and sending them out to the internet, all with its IP address. So whenever you have a proxy like that, a SOX proxy, an HTTP proxy, HTTPS proxy, Frankly, a DNS server is basically a proxy, even though we don't think of it. So if you have an internal DNS server, that counts. As soon as you have that, a couple of things to pay attention to. Place your threat hunting software's span port behind your proxies. That lets you see the incoming connection to the proxy from the client, as opposed to just tens or hundreds of thousands of connections going from the proxy out to the internet. That helps you find the original machine that's causing the trouble very quickly. I think your primary question was, look, it's encrypted from my client to the proxy. How do I tell what was going on inside that encrypted connection? You may not see the actual DNS query in this example I'm talking about today, but you will see the beacon. So the fact that a query is placed in a regular interval, 10 seconds, every minute, every 5 minutes, whatever it is, you should be able to see that on your threat hunting software, whether it's encrypted or plain text, and it doesn't matter what the protocol is or the payload. All right, so let's just take a look at a live demo of this. Go ahead and pull up that blog if you want to see some more details about how this is performed. We're going to look for two things primarily. The beacon behavior, we're going to send these queries every 4 seconds. So I should see somewhere around 900 queries an hour going from the internal machine to the external machine. The second is the DNS behavior, and this is where I place tons of requests all to one domain. And as long as that's unencrypted, good point to the person who placed that question, as long as that's unencrypted, I should see, wait a second, why is somebody asking about so many different objects inside the same communication domain? Do I see both? If I see one or the other, it's probably worth investigating. As we try to go and make clear when we do these webcasts, the fact that you see what looks like a beacon or what looks like a long conversation or has something with an odd user agent doesn't necessarily mean it's malicious, but it's closer to the malicious end of the scale. All right. So let's do the live demo. I'm going to start off with, I have to switch the display a little bit. Hold on a moment, please. To this one. And you should be able to see the screen that I started up on my Mac. Apologies if the font is a little bit small. This is basically the same command that's in the blog. But up here, I started a window where I have this command running. Then that's literally the command verbatim. That stuff that says $ curly brace random is a shell variable that comes up with a random number every time it's called. So I'm basically gluing two random numbers, 1 to 5 digits each, 1 to 3 through 32767, back to back, and doing that lookup to stearns.org. Now, there is an actual DNS server at this IP address. Please don't go and abuse that box. I need that one to work. It is a production machine, and I took that risk for this webcast. But this box is, I'm sending the queries out, and then most of them are getting there, and I'm getting an answer back. Every once in a while, one will get lost. And that's why you see this connection timeout. No servers could be reached every once in a while. So that's the first step. I'm generating the traffic. The second step is that I can go over to that machine and say, hey, did I actually get the request? And so I'm going to switch the window now to the server. And this is what I see when I look at that server, that the DNS query logs. These are the queries coming in from the client. So if I look at, let's say, these two requests right here, it's a random number, .stearns.org that's being looked up, and the first one came in at 9:47:09, second one at 9:47:13, third one at 9:47:17. And if you remember from the previous one, I'll switch back to the slide where we're actually generating the traffic. These queries come 4 seconds apart. There's a sleep 4 between every query. And now we can see that over on the recipient system, we can see these queries come in about 4 seconds apart. All right? So we've just confirmed that the traffic's being generated, it's being received. Now, is it being caught at all? So I'm going to switch over to the threat hunting system. And that is this one right here. And if you look, I have these queries coming in that show there's traffic from the internal system, 10.0.0.41, to the external system. It's a DNS query. And I can see 2 of the queries right here, a randomnumber.stearns.org and a randomnumber.stearns.org. And if you look over here, they're 4 seconds apart. So these are the actual logs from, it happens to be Bro, where I'm capturing the traffic. And so I can see that Bro is actually seeing this traffic fly by. That's most of the confirmation that I need. So the last question is, are we seeing this as something like a beacon or DNS type behavior? So let's take a look at the beacon tab on our threat hunting software. I need to switch the display back for you to Google Chrome. Okay, is that visible now? I'm going to assume if I don't hear anything that it is. Great. Over here, thank you very much, Keith. Perfect. So over here, what you see is a series of queries going across, and it's about the same number every hour. It's about 900 connections an hour. And so what we see is traffic from the internal IP address and going to that same external box I was talking about. If you look in the top center, I don't know if you can see my mouse. I'm assuming you can't. So in the top center, there's a quick note about the recipient system and the protocol being used. Now, in the center right, we look at how many connections are showing up. There are 13,000 connections over the past 24 hours that are happening at 4-second intervals. And because time isn't perfect, you've got just under 2,000 at 5-second intervals. So this is a beacon happening very regularly, about 4 seconds apart. But we also want to check, now that we've checked that the beacons show up, does this show up in as odd DNS requests? And sure enough, if you look up this is the most commonly requested domain. If you look in the upper left, I have 15,000 queries over the last 24 hours. 15,000 objects that have had 45,000 total lookups, all going to stearns.org. Now, that's just way too many for a legitimate domain. So not only did this show up, but it showed up as the first request, as the most likely to be malicious. I'm glad to say that the package that we're using is scoring well on both of these. We'll talk a little bit more about this particular package at the end of the webcast, but for the moment, we're just trying to keep this generic. All the techniques that we're talking about should apply to any threat hunting package that you use. So I'm going to switch back to our presentation. All right. So we saw that we've got DNS requests every 4 seconds. We saw a huge number of DNS requests going to the same domain in a way that they probably shouldn't. And now we can say how this is probably worth investigating. Why is this there? What did you need to make this happen? Almost nothing. A command line on an internal system and a DNS server on an external system. In fact, for this particular test, you could have done this against an IP address that didn't have a DNS server at all. It might not have shown up though. on your threat hunting platform. Your platform might have said, well, there's no machine at that other end, so I'm not even going to track this. So it really is better to use an actual DNS server on the external system if you can. If it didn't show up, you've got a couple of things to do, and I won't show the exact commands. You can find these in the blogs. You have the commands verbatim that you need to use, but in short, you want to look on the sending system and make sure that the sending system is actually creating the packets. You want to look on the external system and make sure the external system's receiving them. If it isn't, you might have a firewall in the way that's blocking the requests. Do you have your threat hunting system connected to a span or mirror or tap or copy port in between those two? And is that port configured correctly to mirror traffic to your threat hunting system? All four of those should be checked. You can also run your packet capture to test whether the packets are showing up on the threat hunting system at all. And I've got those commands over in the individual blogs. You can see those there. One thing to worry about is, well, my threat hunting system detected it, but it was 15 pages down in the results, hidden behind all kinds of other stuff. Now you have to ask yourself, if this was a real piece of malware and it was hidden down inside 15 pages of results, do you consider that a successful catch? I'm not sure I would. You'll have to decide whether it's good enough for you. If our threat hunting software just plain wasn't designed to detect this particular kind of traffic, well, then you just take that into account. And you say to yourself, well, I really do want to capture this, so I need to find a different way to identify this traffic. Or you say, you know, this isn't what our particular package was designed to do. And you say, great, that's fine. That's your judgment for what your system should be able to accomplish. Any other questions about the DNS side of it? Feel free to bring them up and we can answer questions now. We can also answer questions at the end. I think what I'd like to do now, though, is switch over to Keith, who's going to talk a little bit about Metasploit. Let me change presenters.
All right, thank you, Bill. Yeah, that was great. I was going to love a live demo, and I'm glad it went so well because I must have.
I'm glad it worked at all.
Yeah, I'm a little afraid to do anything live.
No.
Yeah.
Chris, what have you got for us?
Hey, so before Keith gets started, we had what I think is a really good question come up, which is around, so in the webcast, we tend to talk about scoring for threat hunting, you know, to be able to identify, is it good, you know, is it evil, what do I have to do? Should that be incorporated into this? In other words, if I'm running, if I'm in the first kind of situation that I thought in my head was that if I purchased a threat hunting tool and it's going off saying, warning, Will Robinson, you know, you've got an attack here and there and here and there and here and there, and they're all false positives. But now you go in and you run the test just as you guys have described, and that sets it off too. Is that really a success? And I'd love to have you guys kind of chat that out a little bit and share your thoughts.
So we wanted to have a way of looking at the different types of threats that were coming in and be able to give the end user a quick way to identify which systems need the most attention first. So I'm just bringing up the dashboard briefly. Sorry, I stole the presenter back from you, Keith. No. This is where you say, for a given, the internal hosts on my system, which ones have the worst types of traffic that I should investigate first. So ironically, the two systems that are listed here are from my home network. I'm sorry to say that my wife's Windows computer is showing up as a worse threat than mine, which is the second one on the list. I haven't figured out how that's humanly possible, knowing exactly what I do with my laptop. But so this is the way that we look at the different threats and glue them together. Chris, was there another aspect of the question?
So that's around a hunter, but I was thinking more, you know, pull the commercial product out of it just from like a testing perspective. Where I was going with that is, If you ran a test and the threat hunting software doesn't see anything, I think we can all agree that is a failure, right?
Yep.
My question was more around, and the question from Dawn was more along the ideas of, so if it detects it, but it generates an alert, but that's the same alert I see 50 times a day for absolutely no reason, is that really a success?
No, I agree. Don and Chris, I agree that that's essentially not a success because you've gotten false positive rate that's so high that it's hiding the real threats. This is just such a tough challenge for all kinds of security tools. If you're sending out alerts all the time and people learn, oh, I need to turn off my alerting system at night because I need to sleep, or, you know, I just know that email alert that comes in, I know that subject line. Yeah, we don't need to even look at that. You've lost. This is a tool that has put itself into uselessness. So I agree. If you've got a system that's sending you alerts all the time and shouldn't, that's failing right there. All right, Keith, apologies. Let me go and send this back to you.
Oh, hey, no problem. That's what we're all here for.
There you go.
Thank you. I'm assuming that it's working correctly.
You're live. Off you go.
All right, great. Thank you. Okay, so now we're going to shift gears a little bit and talk about Metasploit. And I'm going to frame my talk to be very simple. I do understand that many that are attending the webcast may be familiar with this, may work with it often, but I also understand there's many that may not, and may not even heard of this. So we're just going to kind of go at a basic level and then go through all the steps to get this set up. So, and what we're talking about here is the Metasploit Framework, which is free, open source. It's by the folks at Rapid7. There's also Metasploit Pro, which has a nice user interface, and that may apply depending on your situation. But here we're just focused on the Metasploit Framework, which is open source. It's a Ruby-based software, and essentially what it is, it's software for developing and executing exploits. So essentially, you would run this software on a C2 server, basically your attacking platform, and it's going to help you not only create the exploit to run on a host system, it'll also set up the listener for your C2 server. It'll listen for the traffic from your host system or your attacking system. We have a very basic network setup. So what we do is we have our host, which is our victim, which is just a Windows 10 box and a VM. Windows Defender is disabled. On mine, I've disabled it through the registry, so it's not barking at me. And this is an important step. If you're going to try to attack a Windows 10 box, you will have to disable Defender. If not, you're going to get a big old heaping of fail. And it won't be a slow, painful fail. It'll be an immediate fail. I mean, before you know it, it's just not going to work. I got to hand it to Windows Defender. They've done actually a very good job. It's difficult to bypass. So just so you know, that has all been disabled, and that's going to allow us to do what we're doing. So we have our host system, which is our victim. We're connected to the internet, and then from there, we have a C2 server out on the internet with a public IP address. This can all be done in a virtual environment. So you can actually set up your C2 server in a VM as well, and you can network the two together. Myself, my own personal preference, I'd rather do it with a box on the internet with a public IP address, because it, to me at least, it gives me like a higher level of fidelity to where it appears like the attack normally would. So it kind of eliminates a lot of the variables as far as running everything in a VM. As far as installation for Metasploit, it's incredibly simple. If you have not been involved with Metasploit or tried it out, If you do have any apprehension, or maybe it just seems scary or whatever, the folks at Rapid7 have made this so easy to install. If you notice a link there, there's a GitHub page, and if you follow that link to the GitHub page, essentially you're just going to be given the command that you see on this slide. And on your C2 server, which is going to be running Linux, that's what we're talking about, is running all of this on Linux on our C2 server. Essentially, you're just going to run that command. It's going to run through, it's going to install everything for you, it's going to set up your database. It really is dead simple. Years ago, when it came to Metasploit, there was a lot of manual setup. You'd have to, configure your own database. You'd have to do a lot of different things to get it set up. It was a bit overwhelming for a beginner, but as I said, now they've made it very, very simple. So this is actually a great test for anybody who's just getting into this or just wants to play around with it. You can just run the script and it's just going to install. And as you can see here, and this is just to show you how easily it goes. This is my C2 server running Linux. It can be any flavor of Linux that you choose. And you can see at the top and just run the script that's provided by Rapid7, and you can see how quick. In fact, this probably takes maybe 20 seconds and it's done. And it's fully installed, and you can run it from there. You can generate your payloads, you can set up your listeners, you can do everything right from the console to get everything set up as far as getting everything set up for your C2 listener and getting it over to your host. So I'm just going to kind of walk through the steps here as far as setting all of this up. And on your Linux box on the C2 server, once you've installed Metasploit, you notice I have screen. If you're not familiar with screen in Linux, you need to be familiar with it, because it's, personally, I really can't live without screen. And if you're not familiar with it, essentially, you can look at it like this. It's basically like making tabs on a command line. So if you've signed in to your Linux box, you're on the command line, you have a session open, running screen will basically make another session for you kind of in a different window. And the reason we do that is we can detach from our originating session to where we can run different processes in a different screen, and then we can go out of that screen back to our original session, and it will not kill the process. So this is the whole thing basically for setting up your listener on your C2 server. You're just going to put in, as you see on the screen, MSF console, which is going to bring up the Metasploit interface. Once you have the Metasploit interface running, you're gonna see the origination of the command line is MSF5 because it's version 5. And then we're just gonna tell it to use the exploit of multi-handler, which is just the generic payload handler in Metasploit. And then after that, we're gonna set the payload as Windows, because we know we want to attack a Windows box. If it were, like a Mac or Android, and then, we would change that line to whatever operating system we're looking to attack. And then it's going to use Meterpreter, which is a word you may have heard before. And in fact, when I first got into this, I heard Metasploit and Meterpreter, and I thought they were two different things, but it's really all the Metasploit framework. Meterpreter is just essentially a meta interpreter. It's just part of Metasploit. So it's really comes down to it's Metasploit. And then the payload we're going to use is reverse TCP. And reverse TCP is essentially, it's TCP connection, but a normal TCP connection would be our server is going to reach out to our host system for communication. And then the host is going to reply back. When we're doing a reverse connection, we want the connection to originate from our host system back to the C2 server. So it's basically flipping the normal direction of communications. So that's what we're going to do here. We're going to do a reverse TCP connection. And the reason that we are reversing the order of that is if we try to originate the connection from our C2 server, we could be snagged by the inbound firewall of the network. Whereas if the connection originates from within that network, from the host out to our server, it's less likely to get snagged by the firewall. The next thing we're going to do is we're going to set the listening host, and that's the IP of our C2 server in this case. And then we're going to set the listening port, and in this case, we want to use 443, HTTPS or SSL. The next is we're setting it exit on session false. What we're telling Metasploit there is we want to keep the listener running even if our session gets destroyed for some reason. It's just going to keep this listener running. And then the next command is we're going to set verbose to true. And verbose is essentially what we're telling it is if it's going to output any kind of commands or errors, we want to see the full string. We don't want to truncate it or shorten it in any way. And then finally, we're going to run the exploit command, which is going to start this listener. And then the J flag is essentially just telling Metasploit to run this process in the background. And that's really it. This sets up our whole listener. So once we're done with that, I just put a note at the bottom is Control A and Control D will get you out of your screen. It'll detach from the screen and dump you back into your original session while leaving this session running, because we don't want to destroy this after we've got it up and running. And then here I'm just showing you the command line screen of everything I just talked through. And it just shows you how it runs actually on the server itself. And you can see at the bottom that it has printed out some responses that now that we've run the exploit command at the bottom, that it is running as a background, and it's saying the exploit is completed, but no session was created. The session will be created is once we've created a payload and the payload has been executed on our host system and it checks in with our listener. So next we want to create a payload in Metasploit. Again, they've made this so simple. However, we're going to make a very basic and very crude payload. Because this is a test environment, of course, we're not trying to hide what we're doing. We have full control over both machines. So you can go much deeper in Metasploit and do those type of things. But for the sake of example, we're just going to make this very basic. So in order to make a payload, again, it's very simple. In this case, I'm using Venom, which is just a module in Metasploit, comes with the Metasploit package. So as you can see, the command is just MSF Venom. We're going to use the P flag after that, which is just saying which payload we're going to use. And in this case, the payload is Windows Meterpreter Reverse TCP. And then we're going to declare our listening host, which is our C2 IP address, our listening port, which is 443. And then the F flag is the format of our payload. In this case, we're just going to do a standard executable file, so an EXE. And then after that, we can just name the executable file whatever we want to name it. In this case, named freebitcoin.exe, because, you know, who doesn't want free Bitcoin? Of course, you're going to click on that, right? So
I would.
And you can go ahead.
I certainly would.
Yeah, sure. Why not, right? Even though in this case, I was the only one seeing it, but I guess now you're seeing it as well. But and really, in a nutshell, this is how easy it is to work with Metasploit, because you can just run this short string here, and Metasploit's going to generate the whole payload for you. And in this case, you can see I just kind of made a little screenshot of from the server how we just run this string. It creates the payload for us and puts it right in the folder or directory we're working in. So once it has done that, has created your free freebitcoin.exe file. Also on your C2 server, you want to create another directory for public file serving. And the reason we're going to do that is we are going to go from our host system, and we need to access this payload from our host system to run. And then so we're going to create a new directory for public file serving, and then we're going to move the payload into that directory, and then we're going to start a simple server. And I'll kind of walk through this real quick for, like I said, for those who may not have worked in this often. So again, we do want to run this in a screen session. So again, you want to run screen. That way you can run in a new screen so you don't kill your session when you back out of it. And then I'm just going to kind of walk through the steps here. That way it will help you do the same. So we're just going to make a new directory. And this is, we're working out of the default Metasploit Framework directory. We're going to make a new directory just called free Bitcoin. And then we're going to copy the payload that was generated by Metasploit, which is freebitcoin.exe. We're going to copy it into our new directory of free Bitcoin. And then we're going to move ourselves into this directory of free Bitcoin. And once we are in the directory of free Bitcoin that has our payload within, we're just going to start up a Python simple server. And you can see the script for that, which is it starts with Python. If you are running Python 3, you can just put Python 3. And then the M flag is just a Python module. And we're just declaring that the Python module we want to run is a simple HTTP server. And then after that, we're just going to put that we're going to serve on port 8080, which again is pretty much just a default. And what that's going to do is it's going to make this free Bitcoin directory accessible from a browser anywhere on the internet to be able to serve our payload. And again, Control A and Control D to get out of this session. So now that we have that set up on our C2 server, we want to go to our Windows box. And then from our Windows box, we're just going to open any browser. In this case, everything was default, so it's Edge, Microsoft Edge browser. And then we're just going to visit our C2 IP address, which is the one that ends in 135. And then we're going to put :8080 because we want to reach port 8080. And then we're going to see our file, and we're just going to click on it. And when you do click on it, Windows is going to pop up, since it's an executable file, asking you sure you want to run this file. And of course, in this case, just click run. And then, enjoy your elite hacking skills for the moment. Because it does, I must say, when you first start doing this, it does feel good. It's like, wow, hey, I just compromised the system. But don't get too excited because you've disabled Windows Defender, which is a huge step. So that made it very easy for you. And then also is, Windows by default, when you go to run an exe, it's going to ask if you want to. Well, if you're trying to be sneaky and get a payload on a system, of course, that's not the way this is going to happen. But for our testing, this is the best way, at least I found, to do it. So this is just kind of showing you from the Windows box what I was seeing at the time. And you can see that I have a browser window that I visited the IP in port 8080, and that's just showing the directory listing for our directory of free Bitcoin. And it shows our payload, freebitcoin.exe, which I clicked on, and I said, okay to run. And then you can see in Wireshark, myself, I always have Wireshark kind of running in the background just because I like to see the reaction from things I'm doing live so I can see the actual traffic. And as we can see, because our compromised system, the IP is 10.0.2.15, our C2 server is our 67.207.93135, and you can see we have communication. Don't pay attention to test Wi-Fi dot here. I have a Google Wi-Fi mesh, so it's always barking about. Now, if we look back at our C2 simple server session, if we go back to that screen, we can see what has happened. We can see, if you look at my screenshot, you can see actually when the browser checked in, that's the first entry. That's a 16, 55, 28. And then you can see right after that that the payload was served.
Hey.
Yes.
We're getting down to about 5 minutes left. Do you want to kind of go down to how you see this on the threat hunting platform?
Yes. Yeah.
Sounds
yeah.
great.
Let me kind of speed it up a little bit then. Thank you,
Great.
Bill. Okay. Now we can also look back at our TCP handler, and we can see that it actually has started since we've checked.
Hey, not a question, but I wanted to just toss this out really quick because I thought it was awesome. Somebody posted in a comment saying, can I do this all in Netcat instead? Oh, absolutely. If you know your payloads off the top of your head, that's a much funner, more elite way to go about doing this.
Absolutely, yes. Yeah, and I'm glad that was brought up, because actually what I'm talking about here and what I'm showing here is one very simple example. You can do this with many other tools. You can also do many other things with Metasploit itself. So, but this is just kind of showing the process. So we see in our Wireshark capture, I captured actually a 1 hour PCAP, and we can see the communication back and forth between our systems, and we can see it happening about every 30 seconds or so. So what we have is we have a 1 hour PCAP capture. I imported it into Rita for analysis, and then used AI Hunter for the visualization, just because it just shows so much clearer by looking at it in AI Hunter. So we're looking for beaconing activity. So let's see what we got. Drum roll. That's like a horrible drum roll. I don't know what I was thinking there. So, and here's our beacon results. 0. We got nothing. So what's going on? Is our tools bad? I mean, what's going on here? Well, I'd like to use a quote actually that from John Strand. He was like, the best way to bypass beaconing detection is to not beacon at all. And that's exactly what's happening here. Is what this has done is this has opened a session, Metasploit, through our host. It's opened a session and kept it open. So even though it was communicating back and forth, say every 30 seconds, it was essentially a stream of data. It was not reaching out, connecting each time. It opened a connection and kept it open. So you're actually not going to detect any beaconing activity because it's just a constant open connection. So if we're focused on looking for beacons, this is the type of threat that we're just not even going to see. And where we're actually going to find this is by looking at long connections. So we're looking at any system that has opened a connection and left it open. And that's exactly what this exploit does. It opens it, leaves it open. And part of the additional threat with that is it's an open connection. So from my C2 server, I can issue commands at any moment. I don't have to wait for the system to beacon back to me. For me to send a command, I don't have to wait for the beacon to send back whatever it is I requested. It's an open connection that can be served. Another thing I know we're in a bit of a time crunch, but another thing I'd like to point out that even though this was derived from a PCAP capture, when I imported it into Rita will convert it into Zeek logs. And Zeek is very good at inspecting the protocol that's being used and inspecting the traffic that's going across the protocol. And as you can see here on my left red circle, Zeek sees that it was 443 traffic, TCP, but there's no SSL certificate that was seen. Normally after the 443 TCP, we would see another flag that would say SSL. And in this case, there was no certificate seen. So that's kind of another indication that it could be malicious traffic since it's communicating on 443 without a signature. So basically for a recap for this exercise is it established a communication session and left it open. and commands can be issued at any moment. It's not detected as a beacon, but it is detected as a long connection. Now, not everything with a long connection is bad. You could have things on your network like a chat application, like a Microsoft Team Viewer, things of those nature actually work that way, where they'll open a connection and leave it open. However, if you do see a long connection going to a destination that just does not make sense, it's not an application you run on your system, and especially if you don't see the SSL handshake and it's communicating on 443, that's a red flag as well.
Hey, very cool, Keith. Thank you so much.
Thank you.
So what I may do is just real quick go through the last couple slides, and then we're going to switch over to questions and answers. So we can answer any questions that have come up that haven't been covered so far. Here we go. So for more information, please join our Discord server. We would love to have you continue the conversation there. We have links to the different blogs and webcasts, and also our YouTube channel and the threat simulation and overview blog that I talked about earlier. There's more that we can do with this. We want to obfuscate the types of traffic. The blogs talk about that. You want to be able to automate this. So how could you set this up with some form of scripting in your environment to make sure that it happens every quarter? Do you have this as part of a regular audit? And do we include other threat types? So thank you to everybody who's taken part with this, especially for Shelby, Keith, and Chris and KC for taking part. We do have time for a couple of questions, and we'll also stay here for a few more minutes to talk about some of the other things that you can do with threat hunting platform. Chris, what have you got for us?
Oh, I've got an awesome one. We have a question that is there an easy way to do this and introduce jitter like you can with Cobalt Strike? And I'm thinking bash shell script with sleep, but I'm a hack. So what do you guys think?
No,
Can I take the hack one first, Chris? Keith?
No, actually, what I was going to say, like what you said, Chris, is exactly right. And also it's kind of one of the advantages of Metasploit and a lot of the other open source tools is they are highly configurable. So
Absolutely.
Yes, you can go in there, you can introduce jitter. You can actually do, when you do get deeper into it, you can do something that makes this traffic even more obfuscated. In fact, this was a project I believe Egypt at Black Hills was involved with Metasploit.
Yep.
Is that they did find that these open long connections like what we just showed were easily detectable. So working with Egypt and Metasploit, they actually came up with another way of doing this, essentially to where the exploit works essentially the same. It's just that, say, like every 30 minutes or so, it tears down the connection and immediately rebuilds it. So it will no longer show up as a long connection. It'll show up as maybe 30-minute long connections. And the best way to detect something like that is by looking at cumulative talk time. So you're not just looking at just a long connection. You're looking at, say, like a period of 24 hours. How long over that 24 hours have these two systems been in communication? Not in a row, but total time. So,
absolutely.
Yeah, there's a lot of different things you can do and a lot of different configurations. But actually bringing up jitter is a great point as far as when it comes to beaconing. That's a good way to try to mask it.
Yeah, because what you'll find is most detection tools will fall apart as soon as you put in jitter. Most tools are based on k-means clustering, K-MEANS, if you want to look it up. It's basically a way to look for patterns in what looks like a very busy data set. And so long as the pattern is exact, k-means will catch it. So it'll catch beacon signal that's sitting inside of a PCAP. But when you jitter, it's not exactly a repeating pattern. K-means falls apart.
Absolutely.
If you go back to the blogs, we show how to introduce jitter into most of these traffic types.
Oh, awesome. Awesome. Hey, another question was, is Rita compatible with Windows? Hey, I can answer that one. No. Get a real platform. like Linux.
Ooh,
And had another question, which is, what exactly is Zeek? Is it just log analysis? No, it's not. So Zeek is a network recorder. It's not the mistake I see a lot of people make is they refer to it as a network-based intrusion detection system, and it's not. A NIDS is signature-based, meaning it only records things when it sees something it thinks is interesting. Zeek records everything. Zeek is awesome. I used to be an absolute PCAP fanboy. I'm more of a Zeek fanboy these days because it takes up about 1/20th the storage of a PCAP, and just about everything I'm interested in is there anyway. So just something to consider.
Yep.
And that's it for questions that were in the queue. There's a lot of comments of, great job with this. Keith is great at explaining things,
Awesome.
but those aren't questions. Those are definitely statements. You guys did an awesome job. Thank you.
Cool. Well, thank you, and thank you, everybody. I mean, really, it's good to see
Thank
so
you,
many
Keith.
people
Thank
here.
you, Bill.
Oh, hey, little hand. I got a little hand. Hey, can I get a little hand over here?
Yeah. Oh, that's right, Keith. You missed it. So we're into post-show banter right now. We will not say anything useful at this point on. Keith, yeah, when you tried to do a bio break before we started, we did talk about your little hand obsession. So.
Oh, yeah. Oh, man. And I recently moved, it's been almost 2 months now, but my little hands are still in a box somewhere. So
I don't even know how to respond to that.
You need a hand finding your little hands.
yeah.
I love it.
Hey, sometimes I need a little hand.
Yeah.
Hey, thank you, everybody who took the time to join us today. We really appreciate it, and we would love to keep the conversation going. So please join the Discord server. Come and take a look at the different channels. We would love to have you bring up things that you're encountering in your environment, offer mentoring help to other people when you've got an answer. This is so much more valuable to have a conversation going in between webcasts than to say, look, once every 2 weeks for 1 hour, we get to talk about threat hunting. Yep. Now you've got it available all the time. When you've got something in your environment that doesn't make sense, bring it up. Let's go and see if we can find an answer. It's a much more positive way to communicate.
Hey, so I said I'm not going to talk about anything useful, but I kind of feel the need because we did have a couple questions come in around signatures. Like one of the questions was, what signature can I use to detect long connections? And, honestly, that's the point. You can't. When you look at the demographic, when you look at the stats, when an attacker successfully gets a foothold on your environment, they're in for 6 months or more, and it probably won't be you who finally detects them. It'll be an outside third party. Now, if there were signatures to detect this stuff, our stats wouldn't be that bad. The problem is you got to go target the behavior. So, what Bill and Keith were talking about, where, you got to know what a beacon looks like, and you got to know why that's interesting, and you got to go in and look at that. There's no signature for that. There may be for a specific tool. Like, Keith was showing the transfer of like a Bitcoin tool. Could I write a signature to catch that? Sure, absolutely. Now, what happens when they use some other type of cryptocurrency? Well, now you're going to miss that stuff. So signature-based can turn into a little bit of a hamster wheel. You're writing signatures, and the attackers are just constantly changing what they're doing, and you're writing signatures for no reason. So the techniques here are really about to identify the behavioral characteristics of C2 and go in and target those.
You notice we never had to know anything about how the attacker got into the building. We're looking at what happens afterwards. How did the attacker make the communication out of the building?
Or what tool they're using to sustain those communications. That shouldn't matter.
That's right. So for the guy who wants to do this all in Netcat, my hat is off.
Yes,
sir. That's right.
That's
awesome. Girl, my apologies.
Yeah, that's awesome. Yeah, I love Netcat. That's cool.
Yeah. Hey, thank you everybody for taking part. Well, I did want to mention one more thing. We try to keep the product that we sell mostly out of the first hour, but I did want to mention one brief thing. When you're using AI Hunter, we just put out a new version yesterday. Chris, did you want to talk about this, or shall I take it?
Oh, I'm happy to take this if you don't want to, but if you want to, go for it.
Either way. We have a new version out, and 3.8 includes something that we've been promising for a while, and we have gotten more requests about this. I am so glad that the feature's out. It's called Beaker, and this one allows you to remember what programs on a Windows machine are making the outbound connections, so that when you come back in 3 days later and you say, wow, I see this beacon behavior going on from this Windows machine to the outside world. What program is kicking this off? Now you can use the sysmon feature in Windows at type 3 entries. Those get remembered so that you can later go back, click on the beaker icon in AI Hunter, and be carried to a screen that shows you the name of the program that's running on that system. Now you can actually say, that's why we're getting communication to the outside world, and have some kind of picture, especially if the communication happened 3 days ago.
Yep, it'll also show you who's running it. So, what user context is that application running under? So you can go check. Yeah, so you can go check the beaconing traffic and say, oh, Keith, Keith's doing it again. It must be Keith. But hey, from my perspective,
running stuff in PowerShell.
Yeah. Well, but to be honest, dude, if I see, your user context running PowerShell, yeah, I'm not going to worry about it. I know you do that all the time.
Sure.
Now, if it's like a sales or an HR person, I'm going to get really nervous.
Yeah.
That's when we know we're going to have a bad day.
I am so glad that this is part of the package now, because this means that you don't have to go and walk over to every computer under question and start doing forensics on each one.
Yep.
You've got a clue now of which system is causing the trouble, and we think this is going to make all the difference in the world when it comes time to responding to these types of traffic.
Yeah, agreed. It's that it makes host log review so much easier, because one of the problems we have today is context. And it goes back to that signature thing I was just talking about, where we can go, we typically look through our host logs for signatures. Like, did someone fail their login? Did, this other type of thing happen? And it's a ton of false positives. And most of us that have to do system log review hate it. We know how important it is, but we also know that, we're looking for, and I heard this analogy the other day, and I forget who came up with it. It was not me. But, you've got a barn packed to the gills with hay, and somewhere in there is a needle, and you got to try and find it. And that's system log review. It stinks and it doesn't work. And again, that's why bad people can stay on your network for 6 months or more before you detect them, or actually before somebody outside detects them. What that pivot capability allows you to do is it allows you to look at the network and say, oh, wait, that's a beacon. Oh, wait, that's a long connection. Oh, wait, that's a combination of those two. That should not be happening. Let me pivot and go see what application under what user context was running that. Well, now I've just taken that barn that's packed to the gills with hay, pulled out one handful, and somewhere in that is the needle. Well, that's a whole lot easier to find now. I've got real context around my system logs. So yeah, I am super excited about this as well. And we're starting, so now that that's out, I'll kind of give folks a little preview. We're looking at Zeek Agent to be able to kind of bring this capability, not just on Windows, but do it on the Mac and do it on the Linux side as well. For anybody who's worked with us for a while, they know we love Corelight. Zeek is awesome. It's been around for years. It's an awesome tool. I mentioned, I like it better than PCAPs now. They've come out with a new tool that they're just starting to release called Zeek Agent that helps to do this kind of mapping on the Linux side and on the Macintosh side as well. To me, this is huge. So that's something we're going to be looking at going forward too.
Fantastic. If you're interested in seeing some of how Beaker works and how you can actually look at the name of the user and the application that's creating this traffic, Chris, can we put demo in the questions, or do we need another way for people to make that request?
So we don't have the official announcement on the website yet for Beaker. We will within about a week. Part of the problem is I need to help with the content generation for that, and I'm already down to like 4 hours of sleep. Hey, I'm still wearing my Tuesday shirt. We talked about this when all this started. I'm down to like 4 hours of sleep, and that's it. So I need at least one night of 6 hours sleep, and then I can get involved with generating the content for that. So yeah, best bet for now is just watch the website. Under our free tools section, you'll see Beaker get listed within the next week or so.
That's great. And if you would like to be able to chat with us more about it, can people at least send in a note to questions@activecountermeasures.com? That's great.
Absolutely.
If this is interesting to you, go and send an email to questions@activecountermeasures.com, and we'd be happy to get in touch and answer any questions you have. Closing thoughts, guys? Should we just stay here for a couple more hours? I don't think.
Well, I actually have stuff to do.
Yeah, exactly.
I love it.
I mean, this is fun and all, but really, thank you, Bill. Thank you, Chris. And then also in the background, we have Casey and Shelby that are helping support this. And thanks for everybody being here. I mean, this has been...
And to their credit, I thought it was kind of funny. Somebody posted into questions, "This is awesome. I get to listen to you folks, and my wife thinks I'm actually working." And I thought it was cool that the two people that responded first were wives who thought that was funny. So.
Oh, awesome.
Well, this is great because I just get to mumble into a microphone, and my wife thinks that I'm working. So
yeah, exactly.
Right. Exactly. Well, I'd have to agree with that because most of the stuff I'm doing is so much fun. It's not work anyways to me. So I kind of get that same feeling. So
yeah, we all have a problem. That is good. All right, folks.
Everybody.
Thank you.
Awesome. Hey,
it's really
thanks,
great
guys.
to chat with you. We look forward to seeing you on the next webcast. I like your story about the hiring one, but Charles has you beat. I'm so sorry, Chris.
My God.
We had a coworker named Charles who ran the tech support group at a previous company. And I hope he's listening today, but I'll go and relay it to him later that we told the story. He needed to find out if somebody was going to be a good tech support rep. So he would come in with a jar of peanut butter, a jar of jelly, a knife, and a loaf of bread, and he'd be dressed up in nice clothes. And he would say...
Charles is just the perfect straight man.
Oh, yes.
He doesn't look like he has a sense of humor to him. He looks like he's always serious, and that really helps with this, too.
And he's hilarious in his own way. And he would say to somebody, okay, tell me how to make a peanut butter sandwich. And the person would start off with, okay, take 2 slices of bread out of the bag. And he'd take his hand and he'd jam it through the plastic, grab 2 pieces of bread, crush them like hell, and pull it back out. Okay, what next?
Yep.
And by the time he was done with basically every interview he ever did, he was covered in peanut butter and jelly.
And he left people crying.
Yeah. He would take everything they said and totally misinterpret it and see what they did. How quickly do they realize that this guy's an idiot and can't make a peanut butter and jelly sandwich?
I love now spread the peanut butter.
Okay.
You told me to spread it. You didn't tell me where.
That's right. This is the only person in that company who had an actual dry cleaning budget.
Yes.
And every time he had an interview, he would have clothes that he would have to send off to get cleaned because they were totally lost. He would have just destroyed his whole washing machine otherwise.
But there was a method to his madness. If you're dealing with customer support, and for those of us who have done customer support, we know, oh my God, it is amazing what people will do that you just will not expect them to do. And sometimes they'll even seem like they're doing what you tell them to, and they're doing something totally different. So yeah, that was his way to kind of vet. So when you start getting stupid people calling in, can you be detailed enough to make sure they don't go astray? And can you keep your cool when that's happening? And, because, customer calls in, you can't tell them they're a moron. That's just not how it applies. You've got to wait until you hang up the phone with them and then take your 30-second break before your next call and then rant and rave and call them. So
you can't tell them you're a moron? Oh.
Well, you can once.
Yeah,
you can once.
you do exactly once. It's absolutely true. And
that.
that's the last time.
Yeah.
Oh, it's absolutely true. Oh, oh gosh. Oh,